answer a question paper of April 2012. This is 2021. This is the question paper. I will answer 1.2 and 1.3. This is the motion or a vertical motion. The question reads as follows. A tennis player throws a tennis ball up and he's about to serve. The ball took 5 seconds to come back to the same position from which it was thrown. So you are given time here as 5 seconds. And this tennis player, it throws a ball vertical upward and it comes back to the same position from where it was thrown. And it took 5 seconds. So the total journey took 5 seconds. Now, it means that to reach the maximum height, when you throw an object vertical upwards, its speed will decrease until it reaches 0. Then when it reaches 0, it will first stop and changes the direction, meaning the speed will increase as it approaches the ground. So the time taken to reach the maximum will be t equal to 5 divided by 2, which is 2.5 seconds, 2.5 seconds. So t is 2.5 seconds. Also to come down, t is 2.5 seconds. Now the information you need to remember when it comes to vertical motion, if it's upward, the gravitational acceleration is negative 9.8 meters per second. And the velocity when it reaches the maximum height will be 0. Initial velocity is not equal to 0. You must give it an initial velocity. If it's going down, g is positive 9.8, initial velocity 0, and the final velocity can never be equal to 0. So this is the information you need to remember when it comes to vertical motion. Now, to solve this question, we are looking for the velocity 1.2.1, which the ball leaves the player's hand. We are going to use the equations of motion. These are the equations of motion for vertical motion, and this is horizontal motion. So velocity, when it reaches the maximum height, v will be equal to 0 at that point. So v is given, g is going up, will be negative 9.8 meters per second squared. Now the first equation, or the equation gonna choose, is v equal to u plus gt. Where there is v, it will be 0. Equal to initial velocity is what you're looking for as it leaves the hand of the player. Plus, is going up, the gravitational acceleration will be negative 9.8 multiplied by time taken to reach this point is 2.5. So you multiply negative 9.8 times 2.5. And the answer will be negative 0 equal to u minus 24.5. When you take over this term, u will be equal to positive 24.5 meters per second. That is the initial velocity for question 1.2.1. Question 1.2.2 is looking for the maximum height reached by the tennis ball from the player's hand. It's looking for this point from player's hand to this point. So that will be S. An equation that contains the givens as well as the unknown is v squared equal to u squared plus 2gs. So if you make this as the subject, the distance will be v squared. Take this one over, it will be minus u squared divided by 2g. Where there is v squared, when it reaches the maximum height, velocity is 0 squared minus 24.5 squared divided by 2 times is going up is negative 9.8. Then you use your calculator and plug in this. Is 0 squared minus 24.5 squared divided by 2 times 9.8. is negative 9.8. And the answer will be 30,625 meters. So it means from this point to this point, the distance taken is 30,625. But the total distance to come back to the original position where it was thrown, it will be 30,625 multiplied by 2 because it doubles this distance. That is 1.2, answer to 1.2. 1.3, an athlete preparing for her race was jogging at a velocity of 5 meters per second. Question 1.3, so you are given initial condition. This velocity is 5 meters per second, initial velocity. She noticed a barking dog in front of her and she decided to stop. So the final thing she did was to stop. Final velocity is 0. And the time taken was 10 seconds. It says calculate the athlete's acceleration as she notices the dog. As she notices the dog. Now, this athlete's deceleration. The athlete is going to reduce from 5 to 0. So it's looking for deceleration, not the increase in speed, but the decrease in speed. So the formula we can use is V equal to U plus AT. Final velocity is 0. This is the final velocity. Equal to initial velocity is 5 plus acceleration multiplied by 10. So when you take over this 5, it's going to be negative. And this will be 10A. So 10A will be equal to negative 5. And divide both sides by 10, divide both sides by 10. This acceleration will be equal to negative 0.5 meters per second squared. Deceleration is always negative. That is the deceleration. When you calculate acceleration, you always get a positive answer. 1.3.2. 1.3.2. Calculate the accompanying displacement covered by the athlete. So to calculate the distance, this person is going to reduce from 5 to 0. What will be the stopping distance? So the distance will be equal to, we can use any equation that involves distance, acceleration. So we can use UT plus half AT squared. So the distance will be equal to initial velocity is 5 multiplied by the time taken, which is 10 plus half multiplied by acceleration is negative, it will be negative 0.5 multiplied by 10 squared for time. Then you use your calculator and plug in this. This is 5 times 10 plus 0.5 times negative 0.5 times 10 squared. And the answer to this will be 25. So the stopping distance will be 25 meters. And that's all. Thank you.